Good evening, everyone. Today is our surface learning project. Our topic is multiplexing in general and frequency. Our grade is good 40. And this one is our team member. It's by Ho Kun Hee, Muhammad Afi, Muhammad Yusuf, and Ting Si. Now we go into the introduction.
Assalamualaikum and good evening everyone. Today I'm going to introduce the concept of multiplexing, which is a fundamental technique in communication system. As you can see in the slide, multiplexing is the transmission of information in any form, whether it's audio, video or data, from one or more source to one or more destination over the same transmission medium. Essentially, it helps us efficiently share resources like cables or communication channels, making it possible to send multiple signals simultaneously without interference. There are four types of multiplexing method: frequency division multiplexing, FDM, time division multiplexing, TDM, space division multiplexing, SDM, and wavelength division multiplexing, WDM. As I said in previous slide, there are four types of multiplexing methods. First, frequency division multiplexing, FDM, where signals are separated using different frequency bands. Second, time division multiplexing, TDM, which assign unique time slot to each signal. Third, space division multiplexing, SDM, where physical paths like cables or antennas are used to separate signals. Fourth, wavelength division multiplexing, WDM, a fiber optic technology that differentiates signal based on their light wavelengths. We will explore more about each types in the next slides.
Assalamualaikum and hi everyone. My name is Muhammad Yusuf bin Jamal Abdul Nasir and I will be continuing with the presentation to explain about FDM and WDM. First and foremost, one of the methods for multiplexing is WDM, which is frequency division multiplexing, FDM. FDM system can be used in both analog and digital system. With FDM, multiple sources that originally occupied the same frequency spectrum are each converted to a different frequency band and transmitted simultaneously over a medium which can a physical cable or the Earth's atmosphere. In example, wireless. So to say, FDM is a way to transmit signals simultaneously using different frequency bands. Using FDM system has few advantages, of course, which includes simpler technology as it's easier to implement, but of course has few limitations, which are limited bandwidth, which limit the number of users that can share the channel. Another method is WDM, which stands for wavelength division multiplexing. WDM system is a fiber optic technology that transmit multiple data streams using different light wavelength. It occurs optical medium application of ADM and operates in theta hertz frequencies. A few types of WDM is CWDM, which is low traffic spacing at 250 GHz, and DWDM, which is a high capacity spacing at 0.2 nanometers. An example of WDM application is ITU wavelength grid with multiplexers and demultiplexers. That is all from me. I will now pass it on to my next team member to explain the next method
Hello.
of multiplexing.
Okay, so the next will be the space division multiplexing. So space division multiplexing is a technique that increases the amount of the data that can be transmitted through a optical fiber. So actually there will be two methods. There is the smart antenna and the multiple cables. So these SDM will be separate to the spectral channels like the multiple antennas or spherical cables to transmit the signal. So to the next. So the next will be our TDM. Kunal next. Okay, so the TDM will, in other words, will be the time divisions multiplexing. So this TDM is a method of sending multiple signals over one channel by dividing them into short segments. So it is usually used in the telephones, TV, traffic lights. So the TDM digital system will be used in the different time slots for the users. So the variants will be the TDM PAM, which is a direct transmit, and the TDM PCN, which is the digital signal via ADC. And TDM uh, could be categorized into two types, which is the synchronous and asynchronous. So the signal will be transmitted simultaneously over the same channels, but they will occupy different frequency range. So these TDM techniques are commonly used in the AM of FM radio. Okay, next.
Good evening, everyone. Now I talk about the FDM process. We already know what's the FDM. With the FDM, multiple sources with the same frequency spectrum are converted in a different frequency band and transmit over a single transmission medium. In this slide is an example of the FDM system. You can see there are the four channels with the same frequency. They are 0 to 5 kHz. If If the channel 1, 2, 3, 4 is transmitted at the same time, the receiver are difficult to identify the information because each of the signal will be interfaced by each other. So the FDM system is help to solve this problem. And in this example, the channel 1 is modulate a 100 kHz carrier in a double modulator, which inherently subscribe the 100 kHz carrier, and the output of the balance modulator is a double sideband subscribed carrier waveform with a bandwidth of 10 kHz. Next, the double sideband waveform pass through a bandpass filter. This is the BPF, where it is the convert to a single sideband signal. So for this example, the lower sideband is broke. Hence, the output of the FBN occupied the frequency spectrum between the 100 kHz and 105 kHz. The bandwidth is 5 kHz, and the channel 2, 3, 4 has the same process, but the carrier is different. For the channel 2 is 105 kHz oscillator, and channel 3 is 110 kHz oscillator, and last one, channel 4 is 150 kHz oscillator. Then all of the output will be transmit over a single summer and product a FDM output. The next, this slide is show about the frequency spectrum. This is the output of the FDM system. You can see each of the channel have the different frequency band. The channel 1 is from 100 kHz to 105 kHz. Channel 2 is from 105 kHz to 110 kHz. Channel 3 is from 110 kHz to 115 kHz. The last one, channel 4 is from 150 kHz to 120 kHz. So the total sideband of the frequency spectrum is the 20 kHz. So how the receiver to receive the information from each channel, the receiver will be separated by the 5 kHz. So the first receiver will be catching out the first 5 kHz, this the channel 1. The next 5 kilohertz is the channel 2. Then the next 5 kilohertz is the channel 3, and the next 5 kilohertz is the channel 4. So this all about the FDM process. Thank you. So we already know what's the multiplexing system, multiplexing transmission, and the FDM system. So now we go into the quiz. You can scan the QR code. I already put in the chat. You can try.
Yeah, I saw it. Thank you.
Then for your answering the quiz, so we congratulation to to the Isa Firas. He got the 4 question is correct. Okay. Now we going to the summarize. So we already know what is the multiplexing. Multiplexing is a process of the transmission two or more signals simultaneously, and to adjust the capability of the transmission channel. There are the 4 types of the channel: FDM, TDM, SPN, and WDM. So for the FDM, multiple sources that original occupy the same frequency spectrum is converted to a different frequency band and transmit simultaneously over a single transmission medium. So that's all for our surface learning project today. So the last one, can you help us to fill out the feedback? If you cannot scan the QR code, you can click the link in the chat. Then for everyone, for our surface learning project is finished. Okay, thank you. You can miss for this meeting.
Can I get the link for this quiz?
Okay, okay.